Welcome back. It certainly has been a while. Today I want to cover some exciting functionality that comes with KNIME 5.5. And as you can guess, it's about AI agent and agentic AI. I've covered this topic in a beginner fashion in more detail in a Medium tutorial series. I will leave the links to both articles in the description below. But today I really wanted to explore what you can do with AI agents that is a little bit more complex. So luckily it's that time of the year again, where thousands and thousands of people in Germany are very, very busy building up their Kicker interactive manager teams. Last year, I took the time to cover this manager game twice. At the very beginning, I've built a data app that can be used to optimize a team based on last year's results. And then in the mid-season break, I created another data app which allowed to maximize and optimize the team based on the data that's then available from the first half of the season, and to allow optimizing the team in the context of the rules with the number of changes that a player can make. One of the really cool features with AI agents in KNIME is that you can turn any workflow into a tool that your agent can use and interact with. So why not turn my data app from last year into a tool for an agent? Let's see how that goes. So on a conceptual level, this is going to be a fairly easy task. Our main agentic workflow can look like this. We have an agent chat view that is connected to the usual large language model connector nodes. I'm using OpenAI with the model GPT 4.1. And then at the bottom, you can see another input port which passes in a table from the workflow to tool node. And the tricky thing is to create these tools. The first step in order to do this is to break down my beautiful data app from a year ago, so expanding the component, and then thinking about carefully which inputs we need to give this workflow to work and which outputs it should return. If you take a look at the expanded workflow, you will see all these blue nodes. These blue nodes represent one of the widgets where someone can provide data about the team. All of these blue nodes we will have to replace with either a configuration node or a workflow input node if it is a table. In order to make sure that the workflow does not break, it is important that the variables that the configuration nodes generate have the same name as the variables that the widget nodes generated. In order for the agent to understand what data he is supposed to pass into this tool, it is also very important to take some time and write a good description for each of these configuration nodes. Let's now take a look at those nodes that have a table as an output. There are two interactive table view nodes at the top. One of them allows the user to select players that should be part of the team for sure. And the other one allows the user to select players that should not be part of the team under any circumstances. The difficulty in just replacing these with a workflow input node lies in that these tables clearly need to be filtered with those players that should be on, let's call it the include and the exclude list. In the data app, the user can take care of that manually, but now the agent will have to deliver a table that is, let's call it pre-filtered with those players. The only way to achieve that is if we build another tool for that. So for now, let's just remove all those row filters and so on and so forth, and let's pass in a table via a workflow input node. There certainly can be different ways to solve this. However, I decided that the agent could use the fetch players tool to send in the tables of players to be included and excluded. And that is because the fetch players tool will also make sure that the names are correct and that the filtering works right. So this is a final setup. We send in a list of validated players' names to include and exclude as a table into these two workflow input nodes in the green boxes. Those then get passed to a reference row filter, which are connected on the top port to the main data set that has been pre-processed. And we use reference row filter to only include the data for those players that are on the include or exclude list. And that data is then passed to our optimization. Given that the inputs as tables need to come from somewhere, I want to take advantage of the data layer that KNIME has introduced, where an agent can use one tool that generates a table as an output, and without the large language model ever seeing that data, it can pass it as an input to another tool. So with that in mind, I've built a fetch players tool. The setup is fairly simple. We load the data from a CSV file that's publicly accessible and pre-process it a little bit. Then we have two string inputs. One is a simple string configuration input, where the large language model, the agent, passes in a comma-separated list of names. And the other one is a single selection configuration node, which allows to set the mode whether this is the table of players to be included or excluded. And that is important for the column names in the output table. So this is one tool that captures two use cases. And as you can see, at the end, right now, it is in include mode, which means the column header is chosen players. When I experimented with the setup, I found that one of the challenges is spelling mistakes in the player names. So that's why I decided to add another tool that the agent can use to validate player names that the user provides as input. This tool also gets as an input a comma-separated list of player names. Those are the names that the user might mention in the chat conversation. These are then ran past the main data set using a string matcher, and as an output, we generate a JSON object. So JSON is, I guess, a data type and a structure that large language models will be very familiar with, because the web and the data that they've been trained on will have contained lots of JSON. And we simply pass it back as a message in the conversation. So the agent can use this to confirm with the user who's chatting with the agent whether the players that he's found are the right ones. And this way we ensure that once these players are sent to the fetch players tool, that the filtering works all right. With this validation tool built, the overall agent worked quite fine, at least for me. When I tested this with my wife, I found that people that are not familiar with the players who are available and who are playing in the Bundesliga in Germany are struggling a little bit because they simply don't know which players to pick or which players to name. So I thought I'd build one last tool, which is a search players by team and position tool. So the agent can use this tool for people that are a little bit clueless about the Bundesliga to provide some information. For example, what's the maximum market value or the minimum market value that you want to see players for, which positions and which teams do you want to have included, and how many of the players that can be found do you want to have included. This is then generated also into a JSON string that the agent can then use to pass back information to the user to make some choices on which players should get on that include or exclude list. Okay, let's start with a fairly simple example. And to start with, I'll show you how you can actually use this app. I've created this workflow that you can run locally. And when you open it, you first want to add it in your OpenAI API key. You also could do that by right-clicking on this component, configuring it, and pasting your API key into this field. After that, click on that magnifying glass And after a moment, the chat window will appear. I recommend that you then maximize that. And you will get a brief introductory message. And I will just use a simple example. So copy and paste it. And let's add one more player, Ko Itakura. And then let's send it and see how it goes. It will take a moment. And then you get the full chat response in total. So let's go through this one by one. So to start with, our agent used the validate players tool and made plan. It validated the players successfully. So that means that the names are correct. And then it used the fetch players tool and updated the so-called data repository, so the data layer. And after it's done all that, it automatically sends all the information that we've given it to the optimize team tool. And as a response, we then get the nicely formatted summary of an optimized team that includes the players that we wanted and does not include any of the players that we asked to be put on the exclude list. First, let's maybe go through a bit of a more complex example, simulating someone who is not super familiar with the Bundesliga. Let's go through the example. I initially asked it to show me the best defenders from last year. It didn't really bite. So then I asked it again to show me the best defenders and the best strikers. On that request, it then started using the tools correctly and showed me a list of the top 10 defenders and the top 10 strikers. Based on that, I then gave instructions on which players to include and to exclude, and I played a little bit around with how I refer to them in my chat message. The agent then went ahead and used the validate players tool, found the right players, and gave me a confirmation. Based on that, I then went ahead and provided instructions around budget and formation. And then the agent went ahead and did its thing with optimizing my team. And it also excluded those players that I didn't want. So yeah, that's awesome. It worked. I think it's a good point in time to wrap things up. I think this is a nice demonstration of what type of complexity KNIME agents can handle, and also how, let's say, not difficult it is to build agents. I hope you enjoyed the video, and I will leave links to the workflow on my KNIME Hub profile in the description below, so that you can download it if you want to play around with it. I see you next time.